How do you map from an ER diagram to actual database tables? What does a one-to-one relationship look like when you map it to the relational model? What about one-to-many or many-to-many relationships? If you want to learn about ER-to-relational mapping, stay tuned and we'll learn that together in this video. Hello and welcome. My name is Elhelw. I talked in a previous video about database design and explained the different steps involved in that process, including requirements gathering and then building the conceptual model, which usually happens using something like an ER diagram, and then converting from that to the logical design, which involves mapping from that ER diagram to actual database tables. I received some questions about how do we do this mapping and how do we translate from our conceptual model or from our ER diagram to database tables. So this is what we're going to talk about today. This is usually referred to as ER-to-Relational Mapping. This involves multiple steps, which we'll go into in this video. But before I do that, I will describe a simple example that we'll use to explain all these steps throughout the video. And it will also demonstrate actually how to build an ER diagram from the beginning. So our example is, let's say we want to build a simple social media application. So let's start assuming that we've already gathered the requirements, okay? So here are the requirements that we've gathered. We have users. Users have unique user IDs. Users can follow other users. Users can write posts. Posts are text only, but they may include one image. Users can like posts. A user can like a post only once, obviously. And users can comment on posts. Comments are text only, and users can comment on the same post as many times as they would want. So these are the set of requirements that we want to support. The next step would be to build the ER diagram or the conceptual model, right? Which we will get to in a second. But before we get into that, there is something I just wanted to mention, is that there is no one way to create the ER diagram. There is no one right way to represent this data. You could represent this data in a number of different ways. So each person going through these requirements may come up with a different ER diagram, and that's fine as long as it correctly represents the data and it represents the requirements and it supports whatever kind of queries that we want later on, then that is fine. I will do one way in this example, but if you try out yourself and come up with different ideas, that's okay as well. So the first step is to try to identify what are the entities in our requirements, right? So one easy way to do this is to look for the nouns in the requirements. Obviously, it depends on how you write your requirements. So one of the nouns here is the user. We see that user is repeated all over the place. So this makes me feel that user is important enough to represent as an entity in our model. Another thing that is repeated here is posts. So post also seems to be an important enough entity that we want to represent. One thing that I will also choose, but it may not be intuitive, is image. So we mentioned image here, so I will choose to represent this as an entity. Like I said, you don't have to, there might be different ways to do this, but I want to represent this as an entity because it will help me to explain some of the things that we want to talk about today. All right, so right now we have three entity types: users, posts, and images. And we're going to start putting these in our ER diagram. So here's our empty diagram so far. We're going to add the user entity, post entity, and image entity. And then for each of these entity types, we want to add the attributes that we've seen either in the requirements or things that we think would make sense in those entities. So for a user, we have a user ID, which is mentioned in the requirements. Usually a user will have a name. We may also want to store their email address, potentially their birth date. So there might be other information, of course, but let's say this is the information that we care about that we'll store for this entity type. What about the post? I will assume that it will have some kind of ID as well. So let's say it has post ID. We said posts are text only, so we want to also store that, the content of the post itself. So it's going to be an attribute of the post, and also maybe the timestamp or the creation time of that post. What about the image? Again, I will assume that maybe we need some kind of ID for the image. So let's say image ID. And also we want somehow to actually put the location of this image, say, the URL of that image. Again, you might have more information than that, but for simplicity, let's assume that this is what we're looking to store. Okay, so these are the entity types that we have. The next thing is to identify the relationships. Let's look again at the requirements that we have and see how we can find the relationships there. So one thing is this one, users can follow other users. This is a relationship between actually the same entity type, which is users. If you remember, we had an earlier video talking about the different relationships, and this would be called a unary relationship because it's between one entity type and itself. So this is the follow relationship. We're going to add it here on the diagram. So as I said, this is between user and user. Two things we want to determine for each relationship. We want to determine the participation as well as the cardinality ratio. So let's start with the participation. Imagine that this is actually a relationship between two, like if we consider the users as two different entity types. So there's like the follower and then there's the followee. The follower type, does every user have to follow other users or not? You might have a new user that does not follow anyone, right? So it's not mandatory for someone to follow other users. So this means that the participation from the follower side is partial participation. Now, from the followee side or the followed side, does every user need to be followed by someone? That's also not necessary. There could be a user that is not followed by anyone. So participation from the followee side is also partial. So partial participation, we represent that as a single line. Now, the cardinality ratio. From the follower side, how many users can a user follow? So a user can follow any number of users. So this means that it's many. And then how many users can follow any given user? Like from the followee side, how many users can follow that particular user? Also many. So this is the follows relationship, and we identified all the aspects of it. One thing that we might want to add here, we might actually want to add an attribute to that relationship, saying that this user started following the other user at this particular date and time. So we might want to add a timestamp to this relationship. All right, the next relationship is users can write posts. So there's a relationship between user and posts. Let's again identify the participation and the cardinality. So from the user side, does every user need to write posts? No. Obviously, some users may never write any posts, so this is partial participation. Now from the post side, does every post need to be written by a user? Obviously, yes. No post will exist without being written by a user. So this is a total participation. And total participation is represented by a double line. So that's participation. What about cardinality? From the user side, how many posts can a user write? User can write many posts. So this is many on this side. From the post side, how many users can write a post? A post is written by only a single user. So this is a 1 from this side. Let's go to the next one. Now we have the post may include one image. All right, so post and image. We have a contain relationship. Again, let's see the participation. Does every post need to contain an image? No, we said that it may or may not. So this is a partial participation. But from the other side, from the image, does every image needs to be part of a post? Yes, this is a total participation. Now, what about the cardinality? The post, how many images can a post contain? We said a maximum of 1. So have to put 1 on this side. And then from the other side, from the image side, how many posts contain that image? Also 1. So this is a 1-to-1 relationship. The next one is users can like posts. So this is between user and post as well, but this is a like relationship. We already have a write relationship between user and post, right? But we can have multiple relationships between the same entity types. So user can write posts, but also user can like posts. So that's a different relationship between the same two entity types. Now, the participation. Does every user need to like some posts? No, some user may never like any posts. So this is, again, partial. Does every post need to be liked by some users? Also no. Some posts may not be liked by any users, so also partial from the other side. Now the cardinality. How many posts that the user is the user able to like? The user can like multiple posts, so this is many. And then how many users can like a single post? Also many. The next one is users can comment on posts, and comments are text. So we have a third relationship between user and posts. Now let's look at the participation. Does every user have to comment on posts? No, so partial participation. Does every post have to be commented on by users? Also no, so also partial participation. Cardinality, how many posts can the user comment on? Can be many. And then how many users can comment on a post? Also could be many. For comments, we also said that we need to store the text of the comment. We might also want to store the timestamp of that comment, so we'll add those as attributes to that relationship. So this concludes the ER diagram part. So now we have designed the ER diagram. This is the conceptual model. Now we go to the part that we actually wanted to describe today, is how to map from this to the relational model, to the actual database tables. All right, so to do that, we have a couple of steps. First step is look at the entities. We're going to look at the entities that we have in this diagram. For each entity, we're going to create a table. All the attributes of that entity will map to columns in that table. We need to choose the primary key of that table. We have another video on primary keys and other types of keys, so we know how to choose a primary key. But for simplicity, primary key can be either simple or composite. Simple means that primary key contains only one attribute. Composite means it can have multiple attributes. Primary key needs to be not null. You cannot have nulls in the primary key attributes at all. It needs to be unique across the table, so the attribute or attributes that comprise the primary key have to be unique for every row in that table. It also needs to be minimal, so it means that it does not have any extra attributes. It has the minimal amount of attributes necessary to uniquely identify a row in that table. So let's look at the entities that we have and their attributes and see how those will map to tables. So in this diagram, we had three entities, as we discussed earlier: the user, post, and image. And these are the attributes that we have decided. So let's start with the user. So I'm going to define a user table, put all the attributes in that table. And in this particular case, we chose the user ID to be the primary key. User ID is unique, as we have seen in the requirements, so this could be an easy identifier. We could have also chosen the email, assuming that no two users have the same email. But obviously, if we have the choice between an ID and an email, ID is usually easier to deal with. So we're just going to pick user ID as the primary key. The next entity was post. We also had post ID, content, and timestamp. And also we're going to choose post ID as the primary key in this case. Third one was the image. I'm going to call it post image. It had image ID and URL. Technically, either of them could be the primary key because URLs are also unique and cannot be null. But again, an ID is usually easier to deal with and to process and so on. So let's just go with the image ID for now as the primary key in this case. So that was the first step, the entities. Now we have to look at the relationships. We're going to look at each type of relationship separately. So first, we're going to look at one-to-one relationships. For one-to-one relationships, assuming that they are between two entities, S and T, we're going to look at the participation of that relationship. So we have different combinations. First possibility is that both have total participation. If they both have total participation, then one way to represent that is to merge them both into one table. And if we merge them into one table, it means that all the attributes from both tables are merged into one. Also, if the relationship itself has additional attributes, they get added to that table. So this is the first possibility. Second possibility is that one relationship has partial participation and the other has total participation. In this case, we will add a foreign key from T, which is like the relationship that has the total participation, pointing at the one that has the partial participation. That foreign key may also be chosen as a primary key of T. And if the relationship has any attributes, they will be added to table T. Table T is the one that has the total participation. If both have partial participation, then we can add a foreign key from either one to the other. That foreign key might actually be nullable, so some of the rows may have null values in there, and we'll add the relationship attributes to the side that has the foreign key. So let's see which cases of that do we have. So here is our diagram. Again, we're looking for one-to-one relationships. So the one that we have is between post and image. This is one side has total participation and the other side has partial participation. So this is going to be the second case here. So again, in this case, we add a foreign key from the side that has the total participation to the side that has the partial participation. The one that had the total participation was the image. The one that has the partial participation was the post. So foreign key from image to post. So this is our tables so far. We're going to add another attribute in post image to point at post. So this is the foreign key that we have. One thing we also said is that this foreign key might actually become or could be potentially used as the primary key for the post image, right? Why is that? In this particular case, if it's unique, obviously. If a post can have multiple images, first of all, that becomes a one-to-many. So that's not our case. Because it's one-to-one, this means that the post ID, the same post ID, will never appear more than once in the image table. So this means it's unique. It's also identifying for the image, not just for the post. So we can use the post ID as the primary key here. And it will never be null because an image must have a post ID associated with it. So in this particular example, I will actually get rid of the image ID. I don't need it anymore. And I will use post ID as the primary key for the post image as well. And it's still a foreign key pointing at the post table. One thing to note here is that if you remember when we talked about foreign keys, we said that if we try to delete something from the source table and it has something pointing or referring to it, the system will refuse that. So let's say if I try to delete a post that has an image pointing to it, the system will refuse deleting that post. We also mentioned that you could actually modify that behavior to make it so that when you delete a post, it will automatically delete anything that refers to it. In this particular case, I think that behavior will actually be preferable because the image cannot exist without a post. So if you delete the post, you want to automatically delete any images that also is associated with that post. So that's something that you can keep in mind while building your tables. Another note here is that, like I said, you could alternatively design things in different ways, right? So instead of having a post image table, we could have initially designed that to have the image URL as an attribute in the post table, right? I didn't need another table for it. You could have just a URL attribute like an image URL. If a post has an image, then that URL will have a value. If a post does not have an image, then that URL is going to be null. So that would be another potential way to design this. If we need to store multiple other information about that image, then it makes sense to have its own table. But if we only wanted to store the URL, then it could have been sufficient to store that in the post itself. So again, different ways to store data, different ways to represent it, and both are okay. Okay, so we're done with the one-to-one relationships. Let's move on to the one-to-many relationships. For the one-to-many, let's assume that S is the many side and T is the one side. So for that case, we're going to add a foreign key from S to T. So foreign key from the many side to the one side. If the relationship had any attributes, they're going to be added to the S or to the many side. So let's see, where do we have that here? We have only one relationship that is one-to-many, which is the writes, so user write posts. So the one side is user, the many side is post, and we said we're going to add a foreign key from the many to the one, so from post to user. So this is our table. We're going to add this foreign key from post to user, so we added another field, author ID, which refers to the user ID in the user table. This is all we need to do here because we don't have any attributes in that relationship. Next, we're going to look at the many-to-many relationships. For many-to-many relationships, we cannot just add a foreign key from one of them to the other. For many-to-many, we have to actually create another table. So we're going to create a table R to represent the relationship. If the relationship had any attributes, they're going to be part of this table R. This table R, the new table, is going to have foreign keys to both the original tables, S and T. And those foreign keys in R are going to represent the new primary key of R, or part of the primary key of R. We might need to add more information there. This looks complicated. Let's see what that means in the example. So where are the many-to-many relationships here? We have a bunch of them. We have 3 actual many-to-many relationships. So let's talk about them one at a time. The first one that we have is the follows relationship. This is between user and user entities, right? So we said that we're going to need to create a new table to represent that relationship. And that table needs to have foreign keys to both source tables. Both source tables in this case are the user tables. So we need to have 2 foreign keys pointing at user. So back to our tables, we're going to add that new table follows, and it has 2 foreign keys pointing at the user table. One as the follower, one as the followed. And we said that the combination of those foreign keys is going to be the new primary key. Let's check if that's actually correct or not. What does that mean? We want to check whether the combination of follower ID and followed ID is unique. What would it mean for it to be non-unique? To be non-unique, it means that the same user needs to follow another user multiple times. That doesn't make sense. Once one user A follows another user B, you cannot repeat that. You cannot have the same user A follow the same user B multiple times. So this is only happens once. It can represent the primary key. Okay, the next relationship is the likes between user and posts. So again, we're going to have a new table to represent this, and it's going to point at user and point at posts. So here we are. We have a new like table. We have user ID pointing at user, and we have post ID pointing at post. Again, the combination of these 2 foreign keys, is that sufficient to become our primary key? Can the user and the post IDs repeat within that table? Let's look at the requirements actually. The requirements say that a user can like any given post only once. So the same user can like the same posts just once. So that combination will never repeat. So it is unique, and hence it can be the primary key. Let's look at the third relationship, which is the comment relationship. So a user can comment on posts, and comments can have a content and a timestamp. Now, same thing, we'll have to create another table for that and point at both the user and the post tables. So here's the new table. It's pointing at both the user and the posts, and then it has the additional attributes of the timestamp and the content attributes. Now the same question, is that combination of user and post good as a primary key or not? In this particular case, we have a problem. Why is that? Let's go back to the requirements. The requirement said that a user can comment on the same post multiple times. So user John can comment on a post once. Same user John can comment on the same post again and again and again. So the combination of user and post is not unique. So it is not sufficient to identify a row in that table. So for that reason, this cannot be the primary key. We're going to have to add something else to it. So in this particular case, I'm going to add, let's say, a comment ID attribute, and then the 3 of them together are going to be the primary key. I'm assuming that this comment ID is unique within the user and post combination. So if John comments on a post, it's going to have an ID of 1. John comments on the same post again, it's going to be ID 2. If John comments on a different post, that will start from 1 again, and so on. So those 3 attributes together then can identify a single row in that table. So this concludes the mapping from ER diagram to database table definitions. So let's summarize what we talked about today. So again, today we talked about ER to relational mapping, how to map from the conceptual model or the ER diagram to your database table definitions or the relational model. We talked about mapping entities to tables and then mapping relationships to tables. And for relationships, we talked about one-to-one relationships, one-to-many, as well as many-to-many. Each relationship has its own way of mapping, and we've seen that with an example. Just want to emphasize the point that I said earlier is that there are many ways to design a database. There are many ways to represent the data, both in the ER diagram as well as in the relational model. So if you try to design the same example and you come up with a different design, that's totally fine, as long as it captures your data, captures the requirements, and then works well with whatever application that you have on top of that. So with that, I hope that this was helpful, and I hope that it explained well how to do that mapping. If you still have any questions or comments, please add them in the video and I will try to get back to them. Other than that, please hit the like button. Please subscribe to the channel if you have not already. Thank you so much for watching, and I will see you in the next video.